We are going to check out some high-speed water erosion in Norway. This can be found on both sides of the OsloFjord. My favorite spot is this coastline because the erosion is so clean. But what type of erosion are we looking at? You know what a wingtip vortex is? It's a horizontal vortex that forms where flow directions converge. Horizontal vortices are what carved these perfectly sculpted grooves, and the parabolic grooves as well. When water flow encounters an obstacle, a zone of turbulence arises that spins as a reverse eddy. This is the origin of the horizontal vortex, and here it's positioned perpendicular to the current. As it wraps around the obstacle, the vortex goes downstream to make these linear grooves. In low-speed flow, the zone of turbulence expands outwards. But because these grooves immediately wrap to parallel, we are dealing with a very high-speed flow. And the length of these grooves shows how ridiculously powerful the reverse eddy was. There are also these parabolic grooves that don't have an obstacle. This is because the obstacle was later eroded away completely. A simple ledge can also induce this fluid motion, and they can even form on an originally flat surface. But the approved explanation is that they were from rocks that were carried at the bottom of a glacier. So how does a glacier use a rock to carve a parabolic shape? Did it pick up the rock right here and immediately break it in half and separate it and then move it down? This is impossible, because glaciers don't flow with any turbulence, so they simply can't make these. It's in the wrong state of matter. That is why when this theory was first published in '89 by Canadian geologist John Shaw, subglacial meltwater floods of immense volume was the source. He also proposed that this meltwater flood is what made drumlins, which are essentially the same feature, just larger, and usually made out of sediment and not solid rock. You can clearly see how streamlined rocks dominate this landscape. All of these islands have clear signs of high-speed water erosion. You can see how there are streamlined features inside of larger streamlined features. This is the amazing quality of the multi-scale principle of fluid dynamics. Because Norway is high in latitude and has a notable glacial past, that doesn't mean that everything on the landscape was made by a glacier. You have to look carefully and understand the physics of what goes on in erosion to make such features. I highly recommend to all of you that you go on Google Earth and check out this landscape for yourself. It's very interesting and there's a lot of cool things you can find. All the islands that have exposed rock have these incredible features. And there are plenty of islands that are covered in dirt and have tree cover, and we can only imagine what sort of amazing erosional features lie underneath the topsoil. When you're looking at these islands, it's also good to notice how the whole island itself can be streamlined, and you can see all the channels that go in between the islands. So please enjoy the rest of the footage I've collected. And thanks for watching. I really appreciate your guys' support. And please like and subscribe if you haven't already. And if you have any questions, let me know in the comments and I'll answer them. And thanks again for watching, and keep an open mind. But think for yourself and look at the exact features and see how it's all the work of detailed fluid motion. and not a big, heavy, unresponsive glacier. Thanks for watching. Have a great day.